Welcome back to the channel of ChemPacific. In this video, I'm going to discuss with you a very important question about the term symbol of diatomic molecules. And before that, if you're new to our channel, don't forget to subscribe to our channel. And if you like our video, do press the like button. Now, let's get started. Now, the reason behind making this video is like I found a lot of students having a lot of confusion, mostly about the sign which is given the superscript, है ना? वो plus और माइनस ये क्यों और कैसे होते हैं वो लोग अंडरस्टैंड दे आर हैविंग अ लॉट ऑफ प्रॉब्लम इन अंडरस्टैंडिंग दिस एंड समटाइम्स आई फाउंड सम ऑफ देम सेइंग दैट मैडम अगर ऐसा 3 होगा तो माइनस होगा और 1 होगा तो प्लस होगा ऐसा कुछ होता है क्या आई फाउंड देम आस्किंग मी एंड इन दैट केस आई वुड लाइक टू से यू स्टूडेंट्स ऑलवेज रिमेंबर कुछ होने से अगर कुछ हो जाते हैं वो और कुछ हो कभी साइंस नहीं हो सकते हैं दिस आई से स्ट्रांगली ठीक है और ऐसा कुछ भी नहीं है दैट 3 होने से माइनस होता है एंड प्लस अगर स्पिन मल्टीप्लिसिटी 1 होता है तो माइनस होता है ऐसा कुछ भी नहीं है उसका एक प्रूफ मैं बताती हूँ दिस इज एक्चुअली द टर्म सिंबल ऑफ ऑक्सीजन विद दिस इलेक्ट्रॉनिक कॉन्फ़िगरेशन ये जो इलेक्ट्रॉनिक कॉन्फ़िगरेशन है इसका टर्म सिंबल्स ये भी होता है और ये भी होता है तो आपने देखा कि 3 होने से प्लस माइनस दोनों ही हो सकते हैं क्यों और कैसे और प्लस माइनस का मतलब क्या है वो कैसे होता है डेफिनेटली आई एम गोइंग टू एक्सप्लेन यू इन दिस वीडियो टू वॉच टिल द एंड सो नाउ लेट्स proceed. Now this is a question which actually came in CSIR-NET June 2011 and they are saying they're asking for the term symbol of a molecule with this electronic configuration. Okay, so let's see. So let's solve this. Now the given electronic configuration is this. In that case, you can say that till this, from this to this is nothing but this can be represented as closed shell and from this to this is the valence shell. Clear? Outermost shell or the valence shell. And you must notice one thing that only valence shell is considered. This is very important that only valence shell is considered while writing the term symbol. Clear? Now the first most important thing is what is the representation. Now the representation is this. So this is your spin multiplicity, you must be knowing. This is the mod ml value and this right hand side subscript is 0 to 100 and left hand side the most important is plus or minus. Clear? Now the next point is when the mod value is 1 is when the mod value is 0, mod value of ml is 0, it is represented as sigma. When the mod value of ml is 1, it is represented as pi, and when the mod value of ml is 2, it is represented as delta. Now they have already mentioned you in the problem that the valence shell is having the electronic configuration pi unzeroed 1 and pi unzeroed 1. This is the electronic configuration of the valence shell. So what is the meaning of zeroed and unzeroed? I would like to explain you in detail. Now see students, if you're talking about the zeroed symmetry, I will be explaining over here about both the sigma bonding and pi bonding. Okay, so see students, if you're considering the pi bonding molecule or orbital, so you can see कैसे bonding formation होते हैं. ठीक है, ये प्लस है, ये माइनस है, प्लस. So this is how the bonding is formed and it will result in the formation of the electron cloud density here with sign plus and the electron cloud density here with sign minus. Now how to determine the zeroed or unzeroed symmetry? You take a point from here. This is your body center. You must pass through the barycenter and reach exactly the opposite with same equal distance from the barycenter. See, यहाँ पे प्लस साइन था, यहाँ पे हो गया माइनस, सो डेफिनेटली देयर इज चेंज इन साइन. So if there is change in sign on passing exactly the opposite side and passing through the barycenter, then it is said to be ungeared. Clear? So pi bonding is ungeared. Now let us understand pi antibonding. So pi antibonding can be represented like this. Okay, so this is plus, I'm sorry, when it is antibonding, the sign will change. So this is your antibonding. This is plus, minus, plus, minus. Okay, now see, you must pass. So this, if this is your barycenter, you take a point over here, you pass through the barycenter, you reach exactly the same distance opposite to it. See, there is no change in sign. Therefore, since there is no change in sign, therefore it is said to be Girard symmetry. So pi antibonding is Girard. Clear? Now let us understand what happens when it is sigma bonding. So sigma bonding अगर है, sigma bonding molecule orbital, तो क्या हो जाएंगे? तो फिर this is symmetrical. ठीक है? So ये हो जाएंगे आपका ठीक है. So obviously यहाँ पे पूरा प्लस साइन हो जाएंगे. And now what you do is you take a point and you pass through the barycenter. ठीक है, this, if this is your barycenter, there is no change in sign. Therefore sigma bonding is of Girard symmetry. Clear? And what about sigma antibonding? So basically this cannot be represented as minus, हम नहीं represent कर सकते हैं. So the best way to represent the antibonding is हम दोनों को ही प्लस साइन लिखेंगे. ठीक है, हम माइनस is writing a minus sign over here. ठीक है, so this is how it is represented, and then you have the plus 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 plus. So ये antibonding है, so it will result in the formation of this, which is of plus sign. Now you can change the sign. This will result in the formation of this, which is of minus sign. So again, what you need to do is you take a point here and you pass through the barycenter, reach exactly the opposite distance, and you see there is change in sign. And if there is change in sign, this antibonding is represented as ungeared symmetry. ठीक है, so this you have to keep it in your mind. Clear? I hope this is very much clear to you. Now let us move on. तो अगर उन लोगों ने बता ही दिया है that जो इलेक्ट्रॉन्स है ये एक इलेक्ट्रॉन्स जो है तो ये पॉसिबिलिटीज जो है ये 3 पॉसिबिलिटीज हो सकते हैं वैलेंस शेल में. इवन दो दे हैव गिवन यू कि 2 अलग अलग सबशेल में मैं और एक पॉसिबिलिटीज भी आप लोगों को एक्सप्लेन कर देती हूँ for your better understanding. So usually देखो अगर आप कोई भी molecular orbital formation करते हो and if it is p orbitals, if they are engaged in the formation of molecular orbital and you know how p orbitals के जो ml value है वो +1 0 and -1 होता है. वहाँ पे 0 is engaged in the formation of sigma bonding and antibonding and -1 and +1 they are engaged in the formation of pi bonding and antibonding. Now one more thing, for convenience we consider the pi z to be the resulting in the formation of sigma bonding and pi x and y they're considered that resulting in the formation of pi bonding and antibonding molecular orbitals. So the corresponding ml values हो जाते हैं this. Now जो possibilities है first possibilities ऐसा है that they are of opposite spin. When they are of opposite spin, the value of s is equal to plus half and minus half. So overall value हो जाती है 0. Therefore spin multiplicity 2s plus 1 will turn out to be 2 into 0 plus 1 which is equal to 1. Now see what is the mod value of ml. Now this is very easy. You are having one electron in the pi x with the ml value +1 and one electron in the pi y with the ml value -1. So it will result in the value of 0. If you have 0, it is represented as sigma. So with this configuration, you have the value sigma 1. क्लियर. नेक्स्ट पॉसिबिलिटी ऐसा है दैट दोनों ही पाई एक्स में है बट दे हैव नॉट गिवन. मैं थोड़ा सा एक्सप्लेन इसे एलैबोरेट कर रही हूँ फॉर योर बेटर अंडरस्टैंडिंग. उस टाइम भी आपका एस का वैल्यू 0 हो जाएंगे. ठीक है. सो 2s plus 1 जो है इसका वैल्यू भी आपका 1 हो जाएंगे. लेकिन फॉर योर अंडरस्टैंडिंग मैं थोड़ा एलैबोरेट कर रही हूँ. अगर इस टाइप ऑफ कॉन्फ़िगरेशन होते तो इसका एमएल का वैल्यू क्या होगा. 1 इलेक्ट्रॉन is present with value +1 whereas the other electron is also present with the value +1. तो यहाँ पे आपका वैल्यू 2 हो जाएंगे. तो अगर 2 है तो इसका वैल्यू डेल्टा हो जाएंगे. Now see इसका spin multiplicity is 1 so you have 1 delta. Clear? And the last but not the least which is very important, ये configuration भी हो सकता है. You have pi x and you have pi y with सेम स्पिन मल्टीप्लिसिटी. ठीक है. तो इसका जो वैल्यू है ml which is equal to +1 and -1. सो s का वैल्यू क्या होगा. हाफ plus half which is equal to 1 and the spin multiplicity which is equal to 2s plus 1. This will be 2 into 1 plus 1 which is equal to 3. So mod ml का वैल्यू क्या होगा स्टूडेंट्स. You are having one electron with value +1 and you are having another electron with the value -1. तो इसका वैल्यू हो जाएंगे 0. अगर इसका वैल्यू 0 है तो it is represented as sigma. Clear? So इसका जो वैल्यू है ये है 3 sigma. Now one thing I would like to mention you that the term symbol with the highest spin multiplicity over here, this is the 3, is considered to be of lowest energy and this 3 sigma is considered to be accepted and the ground state term symbol for the given configuration. ठीक है. Now About the Jared and unjared symmetry, which I have already explained you, यहाँ पे और एक information है, and that is that Jared into Jared is equal to Jared into Jared is equal to Jared. Jared into unjared is equal to unjared, and unjared into unjared is equal to Jared. But they have already given you that the configuration is pi unjared 1 and pi unjared 1. तो यहाँ पे क्या formula applied होगा? यहाँ पे unjared into unjared, which is equal to jared. So the right hand side subscript is 3 sigma jared. Now the most important part of this video is the sign. Let us understand the sign. Now this sign जो है, this is nothing but it actually represents the reflection under the plane containing the nuclei. जो plane है वो जो which is containing the nuclei, उस reflection से आपका कैसे difference होता है sign में या difference नहीं होता है, that is denoted by the plus and minus sign. तो इसका एक explanation होता है, scientific explanation होता है, ठीक है. So now let me explain that to you. See, if you consider this to be of plus sign and this to be the minus sign, similarly ये भी आप plus sign ले लो and ये minus sign ले लो. So if you consider this to be the pi x, उसका exactly मैंने आप लोगों को already explain किया है that usually the pi z is considered to be resulting in the formation of what? Pi z is resulting in the formation of sigma bonding and antibonding, and pi x and pi y, they results in the formation of pi bonding and antibonding and pi antibonding molecular orbital. ठीक है. So यहाँ पे मैंने लिया है pi x and pi y. ध्यान से देखो students. If you consider this plane which is contained in the nuclei is the yz plane. ठीक है. So this plane in both the cases, so it is clearly visible to you that since pi x and pi y they are perpendicular to each other, therefore this pi yz जो है, this is cutting pi x. This is cutting pi x vertically and this is cutting pi y horizontally, as a result of which in the case of pi x, if you consider after the reflection, so by the plane which is containing the nuclei, after the reflection there is change in sign. देखो plus जो है after the reflection in this yz plane, the plus sign changes to minus. When it is so, it is represented as the minus sign. This is the reason behind minus sign. And the same plane, ये जो आपका yz plane दिख रहा है, which is containing the nuclei, ये yz plane is cutting it into two halves, and after this what happens? After the reflection of this yz plane, there is no change, क्योंकि ये same sign है दोनों का ऊपर नीचे है ना, there is no change in sign after reflection. There is no change in sign after reflection by the yz plane. So this yz plane is actually containing the nuclei. So that is why it is denoted by the positive sign. So see क्या हो जाएंगे? तो यहाँ पे minus into plus will result in the formation of minus sign, provided both of them are of same spin. Because मैंने already बता दिया है that हम इसे same, जो spin multiplicity 3 है, spin multiplicity जब 3 होगा फिर दोनों ही इलेक्ट्रॉन का स्पिन सेम होगा. क्लियर? प्रोवाइडेड दैट दे आर ऑफ सेम साइन. तो आप तुरंत पूछेंगे फॉर एग्जांपल अगर मैडम सिग्मा 1 होता है, सिग्मा जब 1 होता है तब क्या होता है? ध्यान से देखो, जब सिग्मा 1 है तो हमने देखा है कि दोनों का स्पिन मल्टीप्लिसिटी ऑपोजिट होगा. सो अगर इसका स्पिन ऐसे चेंज हो जाता है, अगर इसका स्पिन चेंजेस फ्रॉम दिस टू दिस, ये कंडीशन हम ले रहे हैं, ठीक है, ये कंडीशन ले रहे हैं, ठीक है. Then what happens? Then the sign, if the spin changes, then it will result to the change in sign. Well, sign will also change. रिप्रेजेंटेशन होना चाहिए. तो अगर ये साइन इसका स्पिन चेंज हो जाएंगे तो इन दिस केस इसका साइन माइनस हो जाएंगे. उस टाइम फॉर्मूला क्या होगा? ये तो ऑलरेडी माइनस है, इंटू माइनस इट विल टर्न आउट टू बी प्लस. इसीलिए जब स्पिन ऑपोजिट होता है, स्पिन मल्टीप्लिसिटी 1 होता है, इसीलिए इसका साइन प्लस होता है, और स्पिन मल्टीप्लिसिटी जब 3 होगा, इन दिस केस इसका साइन माइनस होगा. क्लियर? आई होप अभी आप लोग कभी भी ऐसा नहीं बोलोगे कि 3 होने से कुछ नहीं होता है. 3 होने से माइनस इसलिए होता है because the plane, yz plane, which is containing the nuclei, in the case of pi x, there is change in sign after reflection. There is change in sign after reflection by the yz plane, which is containing the nuclei in the case of pi x. So it is represented as a minus sign, and in this case there is no change in sign after reflection by the yz plane, the plane which is containing the nuclei. There is no change in sign, so it is represented as plus sign. So plus into minus is equal to minus. And also when the spins are different, अगर आप यही स्पिन चेंज हो जाएंगे तो उसका यही प्लस साइन जो है, ये प्लस साइन चेंज हो जाते हैं माइनस में. तो ये तो ऑलरेडी मैंने दोनों के लिए ही यही स्पिन लिए थे, तो माइनस इंटू माइनस इज इक्वल टू प्लस. इसलिए जब स्पिन मल्टीप्लिसिटी 1 होगा इसका साइन प्लस है, जब स्पिन मल्टीप्लिसिटी 3 होगा इसका साइन माइनस है. आई हैव ब्यूटिफुली गिवन इन अ नोट फॉर्म, यू कैन गो थ्रू दिस. तो मैंने ये कहा है, देखो द प्लस एंड माइनस सबस्क्रिप्ट. अच्छा, वन मोर थिंग, ये प्लस एंड माइनस सबस्क्रिप्ट आर यूज्ड इन 2 कंडीशन. पॉइंट नंबर 1, ये सिग्मा टर्म्स होना चाहिए. पॉइंट नंबर 2, व्हेन द इलेक्ट्रॉन्स आर मोस्टली प्रेजेंट इन द पाई बॉन्डिंग एंड एंटी बॉन्डिंग. पाई बॉन्डिंग ऑर्बिटल या पाई एंटीबॉन्डिंग मॉलिक्यूलर ऑर्बिटल. ठीक है, तो ये कंडीशन याद रखना. सो फॉर सिग्मा टर्म्स, प्लस एंड माइनस सबस्क्रिप्ट्स डिनोट्स द बिहेवियर ऑफ द मॉलिक्यूलर वेव फंक्शन अंडर रिफ्लेक्शन. देखा, अंडर रिफ्लेक्शन कौन सा प्लेन? इन अ प्लेन जो प्लेन कंटेनिंग द न्यूक्लियाई. तो अगर आप 2 pi x लेते हो and you consider the plane to be the yz plane, then there is change in sign under reflection. And अब जब वो 2 pi y हो जाएंगे, there is no change in sign under reflection. ठीक है, अगर there is no change in sign, then it is considered to be plus, and if there is change in sign, it is considered to be minus. तो ओवरऑल ये माइनस हो जाएंगे. तो ओवरऑल रिप्रेजेंटेशन हमें क्या मिल गया? हमें मिल गया when the spin multiplicity is 3 and it is sigma, then you have Jared symmetry, and then the sign is negative, right? And when the spin multiplicity is 1, matlab both the electrons are of opposite spin, then also it is Jared symmetry and the sign is plus. So this is the proper explanation. I hope this is very much clear to you. If you have any kind of doubt, do write to me in the comment section. I will definitely try to clear your doubt, making a special video for you all. So thank you for watching our video. Thank you.